The vector is one of the fundamental data structures in R. It's conceptually a container of elements stored in sequence fashion, and one of the things you should remember about vectors is that all of the elements must be of the same type. So they must be one of the logical type, so true or false, one of the numeric types like double, complex, or integer, the character string type, or the raw type. In this video, I'll demonstrate how to create and access vectors in R. So I'll take you through this example code piece by piece, and we'll stop and run each section individually and work our way through it. So in the first example, we're going to use the colon syntax to create a sequence of integers that gets stored in a vector. So on line 2, we have v, and we assign that to the vector returned by 1:10. And then on line 3, I just specify the variable v so we can see the contents of it. So if I highlight lines 2 and 3, I'll select the Run Current Line or selection from the toolbar, or use the Control-Enter shortcut to run this code. So I assign 1:10 to v, and I output the contents of v, which is the integers from 1 to 10. So it's a vector containing the values 1 to 10. Now the colon syntax is not limited to an increasing range. Like on line 5, I specify 10:1. So if I run line 5, we get the numbers from 10 to 1. I'm not limited to positive integers. I can use 0 and negative as well. So on line 6, I have -10:10. That gives me all of the integers from -10 to 10. In R, we also have the C function to return a vector. So on line 9, I have C, and in parentheses, I have the values 5, 7, 10, 99, and v. So this will create a vector with the values 5, 7, 10, and 99, and the values from the vector v. So running line 9 gives us those values in the output. We also have the sequence generation function called seq. So on line 12, I have seq, and then in parentheses, I have the parameter from equal to 1.5, the parameter to, the word to, equals 22.5, comma by equals 0.5. So this will create a vector from the values 1.5 to 22.5. So running line 12 gives us 1.5 to 2.53 all the way up to 22.5. I do the same thing on line 13, but I exclude the names from the arguments. So I just have the values to seq and in parentheses 1.5, 22.5, 0.5. So that's a shorthand for the same thing as we had on line 12. Line 15 is an alternate version of seq where we don't specify the increment, but we specify the number of values, the length of the output. So on line 15, we have seq, and then in parentheses from equals 25, 2 equals 103, and length.out, so the length of the output equals 7. So this will give us 7 values equally spaced from 25, including 25, to 103, and running line 15 gives us the values 25, 38, 51, 64, 77, 90, and 103 in the output. Now we'll look at how we can access elements in a vector. So on line 18, I have v, and in square brackets, I have 1. So we say v and the value at index 1. So running line 18 returns the value 1. Now, some languages are 0-based, whereas R is 1-based. So what happens if we try to access the element at 0? So if we have v and 0 in square brackets like we do on line 19. Well, running this gives us integer. So it actually gives us the type of the vector. But there's another way we can get the type is by using the type of method. So on line 20, I have type of, and in parentheses, the vector v. And that gives us the type, but as a character string. So in the output, we have printed integer in double quotes. We can get the number of elements in a vector by using the length function. So on line 21, I have length, and in parentheses, v. And that gives us 10. We can also use a negative index. Now this is a special syntax to give us the vector v excluding the index 2. So v, and in square brackets we have -2, and in the output we get the values 1, 3, 4, 5, all the way to 10, but it excludes 2. We can also specify a range by filtering based on a Boolean expression. So on line 25 I have v, and in square brackets I have v greater than 5. So this will return all the values from v that are greater than 5. And running that gives us the values 6, 7, 8, 9, 10 in the output. We also have the concept of a named vector, where instead of just indexing by numeric values, we can index by strings. So on line 27, I have x, and I want to assign that to the result of the C function, where the first argument is URL equals www.example.com, comma, page equals index.html. So running this gives us a new vector called a named vector. And if I want to access an element of a named vector, like I have on line 28, I have x, and in square brackets, the string URL. And that gives us the named result with URL and www.example.com. Now, since a named vector always returns the pair, if we'd just like to extract the value, we can use the unname method. So on line 29, I have unname, and in parentheses, I specify the vector x, and in square brackets, the string URL. So this will just return the value from the named vector. So if I run line 29, it just gives us the string www.example.com. Now, if I'd like to extract all of the names from a named vector, I can use the names function. So on line 30, I have names, and in parentheses, x. And that gives us a vector of the names with URL and page. And that concludes this demonstration of creating vectors. In this video, I'll demonstrate how to manipulate and perform operations on vectors in R. I'll take you through the example code line by line, and I'll use the run current line after I explain a line. And then I'll describe the output as we progress through the example. So on the first line of code of this example, we have the variable v, which is assigned to the vector 1:10. Then I create another variable w, which is assigned to 10:1. So v has the values, the integers from 1 to 10, and w has the integers from 10 to 1. Now, if we'd like to modify a single value in a vector, we can specify the vector, the index, and assign it a new value. So on line 5, I have the vector v, indexed at 1, and assigned to 2. So if I run each line of code up until that point, we see that the vector v currently has the values 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I'd like to modify a range of values, I specify a particular Boolean expression. So on line 9, I have w, and index of w less than 5, I assign to 1. So any value of w in the vector w that's less than 5 will be reassigned to 1. W started out as the integers from 10 to 1, but now it has the integers 10, 9, 8, 7, 6, 5, 1, 1, 1, 1. Now I'll demonstrate how to delete a vector. So on line 13, I create a vector u, which I've assigned to the vector 1:5. So the contents of u are the values 1, 2, 3, 4, 5. But on line 15, I assigned null, so null in all caps, and emptied it of any values it had as a vector. Now let's have a look at some vector arithmetic. So we can use mathematical operators to add, subtract, multiply, divide, perform mathematical operations on vectors, element by element. So if I add them together, v plus w, like I've done on line 20, I get the results of the addition. So 12, and then 5 11s, 8, 9, 10, 11. So that's the contents of v plus w. I can do the same thing with subtraction. So each of the operations, subtraction, multiplication, division, addition, all perform the operations between the vectors element by element and gives us a result, a new vector, after those operations have been performed. We can also operate with vectors and scalars. So if I have a vector v and I added 10, well, it will add 10 to each element in the vector v. I can do the same thing with multiplication. So I can take v, multiply it by 2, and that will multiply each of the elements in v by 2. So I'd end up with a vector, as I have in the console, 4, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So it's the current values of v multiplied by 2. If we'd like to combine two vectors, so take one vector and append another vector and return a third, we use the c function. So on line 30, I have u, and I assign it to the function c with the arguments v, w. So that gives us all of the values of v and all of the values of w, and if I type u in the output, I get a new vector with 20 elements, the first 10 being from v and the second 10 being from w. We also have vector functions. So these are the functions sum, prod, min, and max. So these are probably the four most common ones. So sum of v adds up all of the values in the vector v and returns their sum. Prod returns their product, min returns the minimum value, and max returns the maximum value. So the sum of v is 56. The prod of v is 7,257,600. The minimum value is 2, and the maximum value is 10. And that concludes this demonstration of manipulating vectors in R. In this video, I'll demonstrate how to sort vectors in R. So let's look at a few examples. So on line 1 of my example code, I create a vector v and I assign it to the function c with the values 10, 2, 1, 3, 5, 8, 4, 7, 6, 9. So by running this, we create the vector v with those values in that particular order. Now, the easiest way to sort this in ascending order is to run the sort function on the vector. So on line 3, I have sort, and in parentheses, the argument v. So running this sort on v gives us the result with the vector 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this doesn't modify v, this only sorts it and returns the values in a new vector. If I wanted to reassign the values, I would have to specify v and then assign it to the result of the sort. Now in line 4, I have an example where we set the order to be decreasing rather than increasing. So the values are in ascending order by default when calling sort, but if I specify the parameter for decreasing and I set that to true, it's going to give me a sort in decreasing order, so from largest value to smallest. So on line 4, when I do a sort v with decreasing equal to true, I get the values, the integers, from 10 to 1. So all of the values from v sorted in descending order. We can also sort string values or character values. So on line 6, I have a vector w, which I assign to the function c with the arguments, the strings, Steve, Bob, Jane, Sally, Alice. So I have these names, and I'd like to put them in sorted order. Well, it'll work the same way as it did with the numeric version, but it puts it in lexicographical or alphabetical order. So if I sort w, it gives me the strings, the new vector, Alice, Bob, Jane, Sally, and Steve. Now there are a few other things we can do with sort. One of them is to handle NA values. So I create a vector u set to c with the arguments 5, NA, 1, 3, NA, 4, 2. Now if I sort the vector u, it just gives me the vector with the values 1, 2, 3, 4, 5. Now, it just discards the NA values, but there are times where I'd like to keep those values and not just discard them. So for that, I have to specify the parameter na.last. So on line 11, I do a sort of u, and I specify na.last equals true. In that case, the result of the sort is 1, 2, 3, 4, 5, na, na. So it put the na values at the end of the sort. And that concludes this demonstration of sorting vectors in R. In R, we have an object called a list. It's a collection of values similar to a vector, but with some key differences. Most notably, a list can contain elements of different classes. In this video, I'll demonstrate some basics on how to use lists in R, and we'll explore my example code line by line, executing each line using the run current line command along the way. So I'll start by creating a list. So on line 1 of my code, I create a variable a assigned to the function list that takes the arguments to the string Steve, the Boolean true, false, NA 5.5, and the vector created by C with the arguments 1 and 2. So this list has 7 elements of different classes. Now, indexing a list is different than a vector. An index in a single bracket, like I have on line 3, doesn't give back the element at position 1. It gives us a slice of the list as another list. So on line 3, I have A, and in square brackets, the number 1. So that gives me back another list. That list contains the value 2, but it doesn't just return the value itself. It returns a slice of the list. So it actually returns another list. On line 4, index A with 1:2. So that will return a list with the elements 2 and Steve. So the first two elements of our list. To index a single element and return only the element using a list, I need to use the double bracket syntax. On line 5, I have A, double left bracket, 7, and then double right bracket. So we're indexing using this double bracket notation. So this will return the element at position 7. And that returns a vector because the element itself is a vector. So on line 6, I have A, I have 7 in double brackets, which returns the vector with the values 1 and 2, and then I index that vector at position 1. So that will return the first element of the vector that's the 7th element of our list A. And in that case, it returns 1. Now, to highlight the difference between the single bracket and double bracket indexing notation, I'm going to use the type of function. So on line 8, I take the type of A, which returns list. But what about the type of A indexed at 1 with the single bracket notation? That also returns a list. But then I take type of A with 1 in double brackets, and that returns a double. That's because the first element of our list was 2, and that got stored as a double type. Now I'm going to create a named list. So a named list has named members, so we can reference the elements of the list by their names and not just the index number. So on line 12, I have B, and I assign it to list of A equals C of 1, 2, and 3. So the named element A is equal to the vector with the elements 1, 2, and 3. Then I have another element, B, which is equal to the vector created by the function C with the arguments 4, 5, and 6. And then finally, the element C, the named element C, is equal to the function C with the elements 7, 8, and 9. So our list B is a list with 3 elements, and those elements are named A, B, and C, and each of those elements are vectors. So now let's look at how we can access elements of B. So on line 13, I use B, and it returns the contents of B. Now in the output, in the console, we have printed $A with the elements 1, 2, and 3, $B with 4, 5, and 6, and $C with 7, 8, and 9. Now we can access those elements individually by using the $, and then the name. So on line 14, I have B $A. So the syntax here is the list name, so the list variable, $, and then the named element. So B $A returns 1, 2, and 3. B returns 4, 5, and 6. And B $C returns 7, 8, and 9. Now we can use that notation to reassign an element. So if I take, as I've done on line 18, B $A, and then I assign it to the function C with the elements 3, 2, and 1, it reassigns A to a new vector. Now, one of the handy functions that we have in R is the str function. So if we'd like to see the structure of the list, we can use the str function on our list. In this case, on line 20, I have str with B, and that shows us the structure of it in the console. So it gives us list of 3 with $A, num with 1:3 in square brackets. So it's a 3-element vector with the elements 3, 2, 1. And likewise for B and C, which are num vectors with 1:3 and elements 4, 5, and 6, and 7, 8, and 9 respectively. We could also use the length function with a list. So on line 22, I have length of B which returns 3 because the list has 3 elements. Now, it doesn't matter that each of those elements are vectors with 3 other elements. We're only concerned with the list and its elements, not with its sub-elements for each of its individual members. Now, one of the other handy functions we have is the lapply function. So this will apply a function to our list and return a list. So you can think of this function as the list_apply function because it returns a list. So lapply on line 24, b as the first argument, our list, and then the second argument, mean, which is the function that's going to get applied over our list. And this returns a new list, but it has the values 2, 5, and 8. So those are the mean of each vector as elements in our list. We could also use the sapply function in a similar way. So sapply on line 26 with b and mean as arguments, it also returns a named vector with the names a, b, and c, but as a vector in this case. And that concludes this demonstration of using lists in R. Conceptually, matrices are just rectangular arrays. We describe the layout of a matrix in terms of its rows and columns by designating the horizontal indices as columns and the vertical indices as rows. In this video, I'll demonstrate how to create matrices in R. So on line 1 of my example, I create a matrix called M and I assign it to the matrix function, and then in parentheses, the first argument, I specify a vector which I create using the C function and the arguments 1, 3, 4, 64, 11, and 34. Then I specify the number of rows in the matrix by setting the nRow parameter. In this case, I've set it equal to 3. Then ncol, which represents the columns, equal to 2. So this matrix will have 3 rows and 2 columns. And then I need to specify how I'd like to fill the matrix. So we have a one-dimensional vector filling a X and Y plane space. So this rectangular array, we have to decide, well, do we want to put the values down the columns first or across the rows first? And in this case, I want to do it by column. So I set by row equal to false. And that will create the matrix. And then on line 2, I just have the variable m to output the contents of the matrix in the console. So the matrix has down the first column, 1, 3, and 4, and down the second column, 64, 11, and 34. For my matrix with 3 rows and 2 columns. If I'd like to extract a single value from the matrix, I can use an index by specifying a row, comma, a column. So on line 4, I have m, and then in square brackets 1, 2, and that will get the value from the first row and the second column. And in that case, it's the value 64. If I'd like to extract a single row, I can specify m, and in brackets 1, comma, leaving the second value empty, like I've done on line 6. And that gives me the values from the first row, namely the 1 and the 64. If I'd like to extract a single column, for example, the second column, on line 7 I have m, and in square brackets I have comma 2. So that's like saying leave the number of rows empty, but specify the second column. And that gives the values 64, 11, and 34 in the console output. Now I'm going to create another matrix called n, and I assign it to the matrix function with the vector with values 10, 10, and 10. nRow equals 3, and ncol equals 1. And that gives me a matrix with 1 column and 3 rows with the values 10, 10, and 10. Now this one is nice because it has the same number of rows as our other matrix. Now since the matrices m and n are compatible in terms of the number of rows, I can bind them together to make another matrix. And I can do that using the cbind function. So on line 11 I have cbind, and I give it the arguments m, n. And this gives me a matrix, a 3 by 3 matrix, with the first 2 columns the same as previously, so the columns from m, but it appends the column specified by the matrix n. And that gives me a third column with the values 10, 10, and 10. Now this doesn't modify the matrices, but it returns a new matrix, which is the one that got printed to the console. On line 13, I pass the matrix to the function c. Well, the c function is going to take the matrix, the values, and it's going to extract all of the elements and return a vector. So A will contain a vector. So if I type A into the console after I've created it, it has the values 1, 3, and 4, 64, 11, and 34. Those are the values we use to initialize the matrix M. Now we can also create a special kind of matrix called a diagonal matrix. Now it's still a matrix as we've created already, but the only values are on the diagonal of the matrix. So if I call the function diag, as I've done in line 15, and give it a vector, so in this case, using the c function, I give it the values 1, 2, and 3. So this creates a diagonal matrix, a 3 by 3 diagonal matrix, with the values 1, 2, and 3 along the main diagonal. On line 16, I call diag by specifying the number 3, so a single value. So what this says is we want a diagonal matrix that's 3 by 3, and it's going to have 1s on the main diagonal. So this will create an identity matrix of dimension 3. So in the output, we get a 3 by 3 matrix with 1, 1, and 1 down the diagonal and zeros everywhere else. And that concludes this demonstration of creating matrices. In this video, I'll demonstrate how to perform some common matrix operations in R. So on line 1 of my example code, I start by creating a matrix. So on line 1, I have M is assigned to matrix, with the first argument being the C function of the values 1, 3, 4, 4, 11, 34, negative 1, 0, 5. So that's the vector that's going to populate our matrix. N row is equal to 3, N col is equal to 3, and by row is equal to false, because I'd like to populate the values of this matrix by column instead of by row. So I'll create that matrix, and then I'll run M on line 2 to see the contents in the console. So in the console, we have the matrix with the values 1, 3, 4, 4, 11, 34, and negative 1, 0, 5 down the columns. The first function we're going to perform is the determinant function. So this is det. So on line 3, I have det or det with the matrix M as its argument. And that will compute the determinant of this matrix. And in this case, the determinant is negative 63. On line 4, I perform a QR decomposition. So on line 4, I have QR with the argument M, and it will perform the QR decomposition and give us the important parts of the QR decomposition. So we get the triangular matrix Q information returned in the QR variable, the rank, which is 3, the auxiliary information, so the auxiliary values, and the pivot used. If we'd like to carry out an SVD or singular value decomposition, on line 5, I do SVD with the matrix M as its argument. And that gives me the important parts of the SVD decomposition. So SVD returns a list with the name values D, so $D, with the singular values of our SVD, and then the canonical U and V matrices that make up the SVD decomposition. On line 6, I use the eigenfunction on our matrix M. So that will give us our eigenvalues and eigenvectors of the matrix M. If we'd like to take an inverse of the matrix M, and it's an invertible square matrix, then we can use solve. So on line 7, I do a solve of M, and that returns the inverse. Now on line 9, I'm going to create a second matrix called N, and I set that equal to diag with the C function with the values 2, 2, and 2 as its argument. So this is going to create a diagonal matrix with the values 2 down the main diagonal. So in the output, we have a matrix with 2, 2, and 2 down the main diagonal, and 0 everywhere else. Now there's two ways to multiply matrices in R. On line 11, I do M star N. So this is the element-wise multiplication. So if we run M times N, we get 2, 22, and 10 down the main diagonal, but 0 everywhere else, because these were multiplied element-wise, and the matrix N had zeros everywhere but the main diagonal. But if we'd like to carry out a matrix multiplication, there's another operator for that. So on line 12, I have M, then I have percent, star percent, and then N. So this carries out a full matrix multiplication of M and N. So those are two important things to remember, that just a single star or asterisk is an element-wise multiplication, so the cells of the matrices are being multiplied individually, and a full matrix multiplication uses the operator percent star percent. And that concludes this demonstration of matrix operations in R. Factors in R are categorical variables, or sometimes called dummy variables. These are stored as integers that correspond to a unique category. In this video, I'll demonstrate how to create factors in R to represent categorical variables. We'll start with this example code on line 1. I have a variable fuel, which is going to be a vector that I assign to the vector created by the C function with the following character values: petrol, diesel, electric, electric, diesel, electric, petrol, petrol, diesel, electric, 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 diesel, diesel, petrol. So what this represents is a survey of 15 cars by their fuel type, either petrol or gasoline type, diesel, or electric cars. So we'll create our fuel vector and we'll output it to our console to determine the values. So there are 15 strings in this fuel vector that have different categories of car by their fuel type. Now we're going to create a factor from this. So on line 5, I have FF, so that's the variable name of my factor, which stands for fuel factor. So FF is assigned to the factor function with the vector fuel as its argument. And the result of that, it looks very much like our fuel vector, but FF, the levels are displayed without double quotes. So in the output, we have levels : diesel, electric, and petrol, representing the 3 different levels. On line 8, I call the levels function, passing our factor FF to it as an argument. And this returns a vector of the 3 levels that we have: diesel, electric, and petrol. If we'd like to extract a single factor from that, say the first one, we can index our levels function because it's just a vector. So on line 9, I have levels, FF, and then in square brackets 1, and that will return the level represented by the first factor. In this case, it's been assigned to diesel, and that's what we get in the console. If we'd like to count the number of levels, there's a function called nLevels. We pass it a factor, and it tells us how many individual or unique levels there are. In this case, there are 3. On line 12, I call the str function on our variable FF to get the structure of our factor, and that returns factor with 3 levels, diesel, electric, and then an ellipsis ... and then some of the information of the values, the integer values that are assigned to the various factors. So it gives us just a brief overview. Now, if we'd like to know how many of each factor there are in our vector, we can call table of FF, like I've done on line 13. And running that in the console, it gives us a tabulation of our different factors. So diesel, there are 5, electric 6, and petrol 4. Now, if we'd like to return the character strings of our factor and get them back, we can use the as.character function passing FF, as I've done on line 15. And that returns pretty much the same vector as our original fuel vector. And finally, if we'd like to get the numeric values from our factors, we can call as.numeric of our factor FF, and that returns all of the numeric values that correspond to our unique categories. And that concludes this demonstration of creating factors. The R data frame is one of the fundamental data structures used by R, along with vectors, lists, matrices, and factors. You can think of data frame as a matrix-like object with varying types, but it also has the concept of rows and columns. In this video, I'll demonstrate how to create and access data frame properties in R. So on line 1 of this example, I create a data frame. This data frame is going to be called coffee because it represents coffee production for 5 different countries. So coffee is assigned to data.frame, and in parentheses we specify the columns of our data frame, and these are named columns. The first one on line 2 is country equals. I'm going to use the C function to create a vector to specify the values of this country column, and they're going to be set to the character strings Brazil, Vietnam, Indonesia, Colombia, and Ethiopia. Then on line 3, I set production equals to the C function of the values 43.4, 24.0, 8.6, 7.6, and 6.0. On line 4, I set the percent column equal to the C function to create a vector with the values 32.4, 17.9, 6.4, 5.7, and 4.5. And then finally, our last column is called increasing. On line 5, I set that equal to the C function of false, true, true, false, true. So it's a column of logical values. Now we create the data frame and then output the results. So the result in the console gives us a matrix-like object with rows and columns. So we have the columns being the values we specified when we created our data frame. Now if we'd like to extract a single column, say the second column on line 8, I do that using coffee, so our variable name, and then in square brackets I specify comma 2. So this says that I want everything from all the rows, but in the column portion in the second parameter, I specify 2 to only get the second column. So that gives us the production values as a vector. We can also get the second column as a list, but we can access that by using the name. So on line 9, I have coffee, and then in square brackets, I give the character string production. So this will get us the production column, which are the production values, but this isn't done as a vector, it's done as a list type. On line 11, I get the first row. I do that by specifying coffee, and then in square brackets, I give it 1 comma, and then I leave the second parameter, the column parameter, empty. And that gives us the country production percent increasing, and then the first row, Brazil 43.4, 32.4, and false. If I'd like to get an individual cell or an individual value, let's say from the first row and second column, on line 13, I specify coffee, then in square brackets, I give it 1 comma 2. And that gives us 43.4, which was in the first row and second column, or the production value for Brazil. I can also get a subset by indexing it in a similar fashion, but by specifying a range. On line 14, I say coffee, and then in square brackets, I say 1:2, comma 1:2. So this will give me the first and second rows and the first and second columns. So in the output, we get country production, then 1 Brazil 43.4, and then the second row, Vietnam 24.0. So it gives us only a small subset of our data frame. We can get the structure of our data frame using the structure function or str function. So on line 16, I have str with the argument coffee, which is our data frame. And it gives me some details in the console. So data.frame, and then it gives me 5 obs dot. So that's a shortened abbreviation for observations. So it says 5 observations of 4 variables. It lists those variables, country production percent increasing, their types, factor, num, and logical. And then it has some brief portion of the values. We can also extract the column names from our data frame using the names function. So on line 17, I call names with the argument coffee, and that gives us country production percent and increasing. And that concludes this demonstration of creating data frames and accessing their properties in R. In this video, I'll demonstrate how to perform some common data frame operations in R. So on line 1 of this example, I reference the mtcars dataset. And running that line of code gives me the entire dataset that's built into R. And this is the Motor Trend Car Report dataset from a very long time ago. Now in this dataset, it has a list of car models, and then it has some information about each of the cars, including the miles per gallon or MPG, the number of cylinders, the displacement, the horsepower, etc. Now, I'm going to use this data set to perform some common functions that we typically carry out on data frames. The first one on line 3 is the head function. So I call head with empty cars as an argument. So that gives me the first 6 values of the data set. The tail function is similar, but it gives me the last 6 values of the data set instead of the first. The dim function gives me the dimensions of the data set. So on line 6, I do a dim of empty cars, and that gives me 32 and 11. So that means this data set has 32 rows and 11 columns. If I just like to get the number of rows, I use the nRow function. So nRow of empty cars gives me 32, and ncol to get the columns of empty cars gives me 11. There's also a summary function that will compute a summary, which gives us a summary statistics of each of the columns in our data frame. So on line 10, I do summary empty cars, and it computes summaries, whether it's appropriate or not, for each of the columns. So if we look at something like the MPG column for miles per gallon, it gives the minimum value 10.40, the first quartile range 15.43, the median 19.20, mean 20.09, the third quartile is 22.80, and the maximum is 33.90. Now we'll turn our attention to another example. Now I'm going to reuse the coffee data frame example from the video titled Creating Data Frames. So I have coffee assigned to the data frame, which has the country production percent and increasing columns for coffee production for 5 countries. So the countries are Brazil, Vietnam, Indonesia, Colombia, and Ethiopia. So I'll create that data frame. And the first thing we're going to do is take a subset of this data frame. So the subset's going to be called coffee_simple. So this is going to be a new data frame created from a subset of coffee. So we assign it to coffee, and in square brackets, we specify comma 1:2. So this will extract the first 2 columns of our data frame and all of the rows. So if we run line 19 and line 20 to output the values, in the console, we get the new data frame with country and production with the 5 values it was assigned to. Now, there's another way to think of that problem. What if we'd like to remove the percent and increasing columns and keep everything else? So I can go back to line 19. Instead of specifying 1:2, I can specify a negative index. So -3:-4. So this will actually remove the columns and give me the same result. So it's going to remove the percent and increasing columns and then keep everything else, which is country and production. So it gives us the same result. It's just another way of thinking of it. Now on line 22, I'm going to change the production values. So I'm going to change the entire column and replace it with new values. So I specify coffee_simple, $production, and then I assign it to the vector created by the function C with the values 41.5, 25.0, 9.1, 8.2, and 5.0. So if we run that command and then output the results of coffee simple again, it gives me a data frame with those particular production values. So we've replaced the old ones. If we'd like to change a single value, we can index the row and column directly. So on line 25, I have coffee_simple, and then in square brackets, 1,2 for the first row and second column. So this will change the coffee production values for the country Brazil to 42.5. And when I output coffee simple again, the production value for the first row and second column is set to 42.5. Now, if I'd like to add a new column, I can do that by specifying a new column name in square brackets and then assign it some values, and that will insert it into our data frame. So on line 28, I have coffee_simple, and in square brackets, I have the character string new_column. So I'm going to call the new column new_column, and I'm going to assign it to the vector created by the function C with the values 1, 2, 3, 4, 5. So if I run that command and then output the contents of coffee simple again, I get coffee simple as it was before with country and production, but I also get new_column with the values from 1 to 5. And that concludes this demonstration of some of the common data frame operations in R. In this exercise, you'll create and populate a data frame, or you can use one of the built-in ones. Then display a single column from the data frame. Display the first 2 rows of the data frame. Get the structure of the data frame, and then modify a single value within the data frame. Now you can pause the video and perform the exercise, and when you've completed it, come back to the video to see what I did. Now here's the example of what I did to carry out the exercise. So I start on line 1 by creating a data frame called pineapples. So I assign this to data.frame, and in parentheses I specify country, which is equal to the vector created by the function C with the values, the strings, Costa Rica, Brazil, Philippines, Thailand, and Indonesia. And then production equals the vector created by C with the values 2.7, 2.5, 2.4, 2.2, and 1.8. So these are countries that produce pineapples and their production values in millions of tons. So I'll run this first line of code and then display the contents of the data frame. So in the output, I have the country in production and the rows of data as I specified when I created the data frame. Now, there are a few different ways to extract a single column from the data frame. On line 7, I use the name with the $sign, so I have pineapples, $production. This gives me the production values. So in the output, I get 2.7, 2.5, 2.4, 2.2, and 1.8. So this comes as a single vector. I can also index the column using the square bracket notation. So I have on line 8, pineapples, and in square brackets I have comma 2, which gives me the same result. I can also get a list of the column if I specify the column name as a string in square brackets. So I have on line 9, pineapples, and in square brackets the string production. And that gives me the column production with the values. Now, if I'd like to return the first 2 rows, on line 11, I do that by using pineapples, and in square brackets, I have 1:2, comma. So this will give me the first 2 rows and all of the columns. The 2 columns, country and production, and the 2 rows, Costa Rica with 2.7 and Brazil with 2.5. To get the structure, I use the structure function. So the str function, which gives me the data.frame of 5 observations of 2 variables, and then it tells me country is a factor with 5 levels, so 1 for each country, and production is a numeric variable with the production values that we assigned it. Now, if I'd like to change an individual value, I can index that value in the data frame and assign a new numeric value or a new string value if I'm changing a string column. So what I do in line 15, I take pineapples, and in square brackets, I specify 2:2, so this is column 2, row 2, and I change the production value to 2.6. So after I make that change, I display pineapples again, and in the second row and second column, the value is now 2.6. And that concludes this exercise on creating and using a data frame.